Hello. I want to go through a couple of average atomic mass problems with you just to make sure that this is a concept that you make sure that you understand how to do. A couple of you actually happen to have problems with this on some of the assessments that we actually did, so I definitely wanted to jump on here and provide some extra support for you just in case you actually need to review this or in case we actually have our final exam and you need to know how to do them for that. So one of the ways that you could actually see average atomic mass problems is in a table like this, where they will give you a list of isotopes and their relative abundance. When you actually do this, the very first thing that you want to check is the range of masses that they give you. So when you're written like this is the isotope symbol, where this is the chemical symbol for the isotope that you're working with. In this case, it would be IR, which is iridium, and then the masses for those particular isotopes. So in this case, we have a mass of 191 and we have a mass of 193. The looking at the mass is extremely important because your answer that you calculate for average atomic mass always needs to fall between the lowest mass that's given for the problem and the highest mass. So here we can't have a mass that's lower than 191 and we can't have a mass that's higher than 193. When we look at this, then you can go to the relative abundance, and if your abundances equal 100%, which they should, then this is how you want to continue to do the rest of the problem. You're basically going to read across it, and you're going to say, I have an isotope that has a mass of 191 that takes up 37.58% of the sample. And that's what these two numbers indicate. Iridium has a mass of 191. It takes up 37.58% of the sample. And then to it, I am going to add the rest of the sample, which is iridium with a mass of 193, which makes up 62.42% of the sample. And that is what is written right here. So I have iridium 193, and I'm going to multiply it by its relative abundance, which is 62.42% of the sample. Once I have each of these amounts multiplied, I then need to divide it by 100 because what I want is out of this whole entire sample, what would be the average atomic mass for one of these particular atoms or isotopes. So there's 100%, so I'm going to divide it by 100. And when I do this calculation, I end up getting 192.25, and then AMU stands for atomic mass units. Now, does this answer make sense? 192.25 AMUs falls between 191 and 193. That's a good sign. It also is closer to 193 than it is to 191, which also makes sense because you have a greater percentage of your sample that has a mass of 193 compared to 191. So the answer to problem number 1 is 192.25 atomic mass units. Problem number 2. It says here that a teacher by the name of Mr. McCall gives you a sample of carbon that is made out of the following: 24 atoms weigh carbon or carbon, they have a mass of 14, 60 atoms of carbon have a mass of 13, and 516 atoms in the sample are carbon with a mass of 12, and you want to find the average atomic mass of carbon, right? So here again, you are just going to read down the problem. So the first part says you have 24 atoms with a mass of 14. That is the first part that is indicated in how you're setting up the problem. To that, you are going to add the 60 atoms that have a mass of 13. So we're going to take 60 and multiply it by 13. And then to these first two amounts, we are going to add the last part, which says 516 atoms that have a mass of 12. And that represents the last portion of this problem. But in order to find the average atomic mass of one carbon, we need to know the total number of atoms that are in the sample. In order to do that, we calculate all of the amounts that have the unit atom after them. So here we have 24 atoms, 60 atoms. That would give us 84 atoms. And then if we add 516 to that 84, we get 600 atoms. So you're going to take this amount plus this amount plus this amount, which is 7,308. And then you're going to divide it by 600, and here you get 12.18 atomic mass units. Again, the mass answer is between your lowest mass, which is 12, and your highest mass, which is 14. It is closer to 12 or 13 than it is to 14 because the vast majority of your sample has a mass of 12. And then the next highest has a mass of 13. So it would make sense that your mass would be closer to 12 than 13 or 14. The very last problem I'm going to do with you is problem number 3. Here's another one um, for average atomic mass. This one is dealing with the atom lithium, which is the third element on our periodic table, Li. And so lithium occurs as two isotopes in nature. It says the first isotope makes up 7.3% of the sample and has a mass of 6 atomic mass units. The second isotope has a mass of 7 atomic mass units and it makes up the remainder of the sample. And it wants you to again determine the average atomic mass. So here, our very first isotope, they tell us has a mass of 6 atomic mass units, and it takes up 7.3% of the sample. So that's the first part. And then to it, we need to add the second part or the second isotope of the sample. It tells us that it has a mass of 7 atomic mass units. So that's here. And then it makes up the remainder of the sample. Remember that the entire sample is always 100% unless they actually break the atoms down like they did in problem number 2, in which case you are going to need to count the number of atoms in order to get the total number of the atoms of the sample that you need to divide by. But here they just give you percent, so it will be based on 100. So in order to find the remainder of the sample, you need to take 100% and then you need to subtract 7.3 from it because that is the percentage of the sample that has a mass of 6. And then all the rest of it, which is 92.7%, has a mass of 7. And that is why you see this part of the problem. So once you have everything accounted for, your atomic mass unit and the percent that it takes up, you divide it by the total, which is 100%, and you get 6.93 atomic mass units. Here again, the answer is between 6 and 7, which would tell you that it's a viable answer, and it is much closer to 7 than it is to 6 because 92.7% is a much larger percentage than 7.3. I hope that this has actually been helpful for you in learning how to do atomic mass units and average atomic mass for isotopes. Thanks so much for stopping by.